Alright, so ladies and gentlemen, the first thing that I did was I wrote down the law of sines. Mr. Fournier just proved this in the last video for you. So here we have the law of sines. We know that the sine of angle A, the ratio of the sine of angle A to the side A is equal to the sine of angle B to side B, which is equal to the sine of angle C to side C. Now, just to make this clear, really accentuate that A, B, and C are capital there and they're lowercase here. Again, we use A, B, and C lowercase to represent side lengths, and then we use the capitals to represent the angles. So just be careful with that. Okay, now the directions we're going to give you a lot are to solve the triangle. What we mean is every triangle has 3 sides and 3 angles. We want to know about every side and every angle. So what I might recommend we do is kind of make like a little chart. Okay, so I made a little chart here, and I want to see the information that we have. I guess I'll fill it in the chart after I fill it in on the diagram, because really interacting with the diagram is the most important. So we know side A is a length of 16. We know angle A is 97, and we know angle C is 21. Now keep in mind those are degrees and those are degrees. Alright, so I'll put this information in my chart as well. I think it's a good organizational tool. Angle A is 97 degrees, angle C is 21 degrees, and we know if we put those two together we'll be at 118, which means that we have 62 degrees left over to make our way to 180. So angle B is 62 degrees. So we also know that side length A is 16. So traditionally, to solve the triangle, we'll give you 3 parts. And since I gave you 2 angles, we could figure out the third angle pretty easily, just to make sure everything sums up to 180. And so really our challenge is to find how big B is and how big C is. And again, these are side lengths, so side B and side C. And we will use our information from law of sines here to do that. So it's kind of nice to make the chart to see everything that you're given, everything that you have, and everything that you will need to find. Okay, so let's try it out. Let's try and get side B. Well, I do know that the sine of angle B, that's going to be the sine of 62 degrees, I do know that that is equal to the sine of 62 over side B, which is what we're trying to find. I know that that ratio is the same as, where should I focus? Well, I do notice that I know the length of side A and the angle of side A. So I'm going to really use those 2 bits of information because they're incorporated. They're related. We'll actually know this entire piece right here because we'll know angle A, we can take the sine of it, and we'll also know the length of A. So you really want to look for a situation where you have an angle that you know of and the side opposite it. That's a really good clue for you're probably going to be using the law of sines. And notice how I abbreviated LOS. Alright, so we'll use, and we're going to use this in both situations, to solve for B as well as to solve for C. So the sine of 62 over B, those 2 sides go together. Those 2 components go together, a side and an angle. And now, like I said, we do know the sine of angle A, and we know the side length opposite that. You need a ratio where you know the numerator and the denominator. So now we have a proportion where we know 3 out of 4 things, and we can just kind of use our calculator and get the rest. So what we'll do, I have my handy dandy calculator right here. Make sure that you're in degree mode. The sine of 97 is 0.99254, and okay, 0.99254. From there, 46, let's say, over 16. I know that I want to know what B is, and the sine of 62. That's going to be 0.882947. So we're going to use this region. We're going to use this as well to get how big side C is. So what I will do is, now you could cross multiply. Since I have a calculator, I might choose to do this. Cross multiplying really doesn't make any sense to human beings. It's just something that people, it's some weird recipe that people follow. So I might think about, well, hey, what is this whole thing as a decimal? It's 0.602034, okay? And then I've got 0.882947 over b. Since I'm trying to solve for b, the inverse of division by b is multiplication by b. So I'll multiply both sides by b. b over b is 1. Okay, and now I want to get b alone, so I'll divide by 0.62034. I guess that really didn't help me much. I'll divide this side by 0.62034. I'm kind of running out of space, so I'm hoping that your notes are going to look a little neater than this. But in the end, b is going to be 0.882947 divided by 0.062034. And there are a bunch of different ways to do this problem, but in the end, I get the length of b, notice that's with a lowercase because we're dealing with a side length, to be 14.233275. Okay, so now I can fill that in my chart. 14.233 with a little bit of rounding. Okay, so now what you're going to do, and since I'm running out of space, I can kind of set you up though. What you'll need to do is you'll need to figure out how big side C is. And another thing you can do to just kind of check yourself, notice how angle A is the largest angle in this triangle. That means that side A should be the biggest side. So when I found B to be 14.233, yada, 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 I'm happy because I have a smaller angle here at angle B, so side B should be shorter. So I feel pretty confident that I did the work correct. Okay, so this is going to be for you. We're now going to use that same ratio that we kind of grabbed onto because we knew side length A and angle A, and we're going to make another proportion. The sine of 97 over 16, that will also be equal to the sine of angle C, which is 21 degrees. And we're trying to solve for side C. So there are a few things you could do here. Cross multiplying is an algorithm that doesn't make sense to most students. It's just a pattern that they follow. But you could cross multiply. In the end, you want to figure out what this is on your calculator, what this is on your calculator, and you guys have done enough proportions during the year where you should be able to solve for C here. And then you can put it in on your chart, and then you've solved the triangle because you know all 6 bits of information. 6 sides and 6 angles. And remember, the key, what is the key to this problem? It's visualizing what you're given and then recognizing that you are given a side length and its corresponding angle. That was the key bit of information, because then we were able to figure out the other angle, and then we could figure out the missing sides from there. So that's the most crucial part of this example. All right, so make sure you solve for C on your paper. So now, in this second example, we need to draw our triangle. It always helps to have a picture. Again, when they say to solve triangle DEF, what that means is figure out the measure of every single angle and every single side. 6 things in total. So let's draw a picture. It's not going to be to scale, and that's okay. D, E, F. So those are the angles. They're capital. Opposite side, angle D will be lowercase side d. Opposite angle E will be lowercase side e. Opposite angle F will be lowercase angle side f. That gets confusing. I hope I didn't confuse you more there. All right, so we have our triangle. Let's write in the information we have. We'll make a handy-dandy chart, and we'll go from there. So angle D is 45 degrees. Angle E is 73 degrees. And F is 10. Okay, so I'm going to make my chart here. All right, so I've got angles D, E, and F, and then I have sides D, E, and F. So real quick, you should have that knee-jerk reaction to say, okay, well, let's figure out the last angle. As of right now, we don't necessarily know that we should be doing law of sines because we don't have a side and its corresponding angle yet. We don't have an angle and the side that's opposite it. So we do know that 73 and 45 makes 108, which means we have 72 degrees left over to get angle F. So now we have all the angles, which, it's not the hardest thing to do in the world, but it's an important piece of this problem. Okay, and then we also know that side F is 10 units big. All right, so now you should be happy because now that you figured out that angle, you have an angle and its corresponding side, so now you can really use the law of sines. We're going to essentially say the sine of 72 degrees over 10, that's going to equal the sine of 73, that's angle E, and corresponding side E. We can also say, notice how again we're going to use the sine of 72 over 10. We can also figure out how big side D is as well. We'll find the sine of 45, and we can figure out how big side D is. So now from here, it's really just some calculator work to figure out how big E is and how big D is. Now, to be clear, I would make a wager that when we do our math correctly, side E should be a little bit bigger than side F. Opposite side F is a 72-degree angle. Opposite side E is a 73-degree angle. So I'm going to bet that E is just slightly bigger than 10. And that'll be a good way to baloney check my answer. All right, so I will solve one of these completely, and you shall do the other. All right? So sine of 72. That's going to be 0.951056 over 10. Sine of 73. You can actually hear me pressing the buttons. I'm hiding out in the science room right here. 956,304, talking to myself, equals E. Now from here, I'll go the whole way. You could, let's say, cross multiply. I would say, I don't need a calculator for this, I can actually say what 0.951056 is divided by 10. Dividing by 10 is just like moving the decimal 1 over. So on the left-hand side, I'll have 0.951056, and don't forget, all I did was I just moved the decimal over 1. That's what happens when you divide by 10. Okay? So that's the left-hand side. You could just do that on your calculator if you don't feel comfortable with it. And now I have 0.956304 divided by E. If I want to solve for the number E, I will multiply by E to undo division by E. Keep in mind this is not the number E. You'll learn about that later. And, okay, I'd really like E to be alone, so I'll divide by 0.951056. 0.951056. And again, I'm running out of room, so this is a little messy. I hope it doesn't throw you that I divided both. I divided both sides by E. I'm sorry, I multiplied both sides by E to undo division by E, and then I divided both sides by 0.951056. It would be nicer if you showed this in 2 steps, and it would be cleaner and neater, but for space issues, I have not included it here. So, pretty nicely, though, 0.951056 over 0.951056 is 1. I'll have E over here, and then I just have whatever this mess is, this 0.956304 divided by 0.951056, and I can just do that. 0.956304 divided by 0.951056. I'm getting E, and I have a decimal issue. There should be a 0 there, excuse me. So then we should have 10, a smidge bigger than 10, 10.05518. and I can't fit that, but so 10.0552 should be your final answer. 10.05512. That's how big E is. And remember, we probably did it right because E should be slightly larger than F because angle E is slightly larger than angle F. So now all you have to do is find D. Now keep in mind, you used this information, because remember we were able to deduce an angle and the side opposite it. So we're going to use that angle, the sine of the angle and the side opposite it, use that same information to figure out how big D is. So you must solve the triangle completely to figure out how big D is. And remember, to solve the triangle, that means to find all 6 components. So now in this problem, I'm going to recommend that you draw your triangle out, make sure you label all of the sides and all of the angles, make a nice neat chart, and then try and find an angle that you know of with the side length opposite it that you also know. And then just rock out law of sines and find the missing pieces. All right, make sure you do this and also the other proportions on the last 2 examples. And good luck and have a trigonometric day.